Alright, in this video I'm going to be looking at angles outside 0 to 2 pi on the unit circle. This is the second part of the third lesson in College Algebra Unit 14. Okay, I've been having some technical difficulties recently, so I'm having to I'm basically standing up at the board and going to have to like shout over towards the microphone. So, the audio on this one might be even worse than usual. So, you're going to have to forgive me on that. All right, so we know that, in general for the unit circle, that 0 radians starts here. What we would call the positive x-axis is kind of the beginning of our angle, the initial side of the angle, and then, if we're going to rotate, say, theta radians, then that's the terminal side. Okay, so this is theta. We also know that, this blue theta is less than that green theta. That's more. As theta increases, we're rotating counterclockwise. Let's say theta increases. Now today we're going to look at, we were just up to this point only looking from 0 up to 1 rotation around the circle, which was 2 pi. So, today we're going to be looking at what happens after you go past 2 pi and keep going. Okay? It's not a big surprise. It does exactly what you think it would do. Okay? And then we will also look at what happens when you go backwards, when you go clockwise. Okay? As you might expect, theta decreases. When you go clockwise. It's the opposite way. So, negative angles, if you saw maybe like negative 2 pi over 3, well, if you know where positive 2 pi over 3 is, how far you've rotated, you can just go in the opposite direction and you'll be able to figure it out. Alright, yeah, so they're asking, where is negative pi over 2? Well, I know where regular pi over 2 is. Right up here at the top. This is positive pi over 2. Meaning we rotated that far. So if I want negative pi over 2, I'm going to go that same distance in the opposite direction. Alright, and then 5 pi over 2, well that's positive. Alright, so, but if you think about it, 2 pi, when we've gone all the way around the circle one time, that's 2 pi, which is 4 pi over 2. So to get from 4 pi over 2 to 5 pi over 2, I'm going to have to add another pi over 2. So that's 5 pi over 2. Really what you're going to do is keep rotating. It's bigger than 2 pi. Let's see. Okay, yeah, and then where we're headed is we're going to look at things like, sine of negative 2 pi over 3. Or if you're going on to a calculus class, something like cosine of 3 pi is something that I saw come up in my calculus class not too long ago. So, trig for angles outside 0 to 2 pi, that is sine of negative 2 pi over 3. Well, again, just like I told y'all earlier, kind of like a 3-step process. You're going to first locate the angle on the unit circle. Then you're going to draw one of your right triangles, or if it's one of the extreme values, you can write the coordinates on the circle. That's also an option. And then third, you can either do SOHCAHTOA, or you could just, know that sine is the y coordinate, cosine is the x coordinate, and to get tangent, you divide y by x. It's kind of what I recommend doing. Okay, so sine of negative 2 pi over 3. Okay, well, we need to find out where negative 2 pi over 3 is. What I'll say is that regular 2 pi over 3 is about right there. Right? Okay, meaning that if I wanted 2 pi over 3, I needed to go that far. But I need to go that far in the opposite direction. So I'm going to go that same distance. And here it is, located negative 2 pi over 3. There, negative 2 pi divided by 3. Alright, I've located theta on the unit circle. Then I'm going to draw a special right triangle. Right, so I'm going to go over here from the origin. Oh, that was really bad. It'll do. Right, and if it's 2 pi over 3, that's a 30, 60, 90 triangle. You know, the ones that are divided by 3 and divided by 6 are 30, 60, 90 triangles. Whereas the ones that are divided by 4 are 45, 45, 90 triangles. Okay? So we know that for a 30, 60, 90 triangle, the short leg is a half, the longer leg is root 3 over 2, and the hypotenuse is 1. Okay? And since we're in the third quadrant, both of these legs are going to be negative, okay? Because x and y are both negative. And if you wanted to, you could label the coordinates of this point on the unit circle. X went left a half, and we went down square root 3 divided by 2 units. The 1 is always positive. The radius is always 1 of the circle. That's kind of how I have explained that in the past. Is that, well, the radius is constant, so we're just going to always let that be positive. In a different course, you might study polar coordinates, and that would be a situation where you would start to let the radius go negative, and all of a sudden it would just basically be, looking back across the circle. But we don't need to worry about that for now. Okay? And then I'm going to say, well, sine corresponds to the y coordinate. Okay? So that's this guy right here. Maybe you could talk about it as the opposite over the hypotenuse. Either way, it's going to be negative root 3 over 2. Alright, so now I'm going to do a few more examples. Yes, cosine of 3 pi, like I said, this one came up in, I don't remember what context, but we were doing some calculus or something, and that was like the last step. It's like cosine of 3 pi. I'll tell you, it's negative. But first, we're going to observe the three-step process. Okay, first, we're going to locate the angle on the unit circle. Okay, well, I know that this is 0, and this is pi, and this is 2 pi. So pi is like half the circle. So the third pi will go back over here. So this is 3 pi. Okay. Well, I know I don't even need to draw a triangle because that's what we did last time. We just drew the coordinates. And I know there's a circle with radius 1. So that the coordinates of this thing are negative 1 and 0. Okay. Well, cosine is the x coordinate on the unit circle. So I'm going to say, okay, so negative 1. And then cosine of 17 pi over 6. Whoa, that's a lot of pi over 6. Okay, that's clearly larger than 2 pi. So what I'm going to say is that I'm going to do a little bit of arithmetic with this one. If you don't immediately see where this is going to be on the unit circle, like it's, I feel like 13 pi over 6 would be something that you could do. It's like, okay, 12 pi over 6 is 2. Then you just add one more, so it's pi over 6. But that isn't what this is. Okay? So 17 over 6, 17 pi over 6, is is going to be 12 pi over 6. That's the first time around the unit circle, back to where I started, plus an additional 5 pi over 6. So, okay, I know where 5 pi over 6 is. It's almost all the way to pi, right here. Okay. So, we can draw ourselves a right triangle. And we can label the size. It's going to be a 30, 60, 90, because it's 17 pi divided by 6. Okay, so the short leg is a half. The longer leg is root 3 over 2. And the hypotenuse is 1. Since we're in the second quadrant, means we've gone to the left and up. So that horizontal one needs to be negative, but the vertical one will be positive. Okay. And if you feel like it, if you like doing this, you can write down the coordinates. So that's negative root 3 over 2 and 1 half. I'm having trouble with the pens over here, so my handwriting is looking a little rough. Okay, but I know that, let's see, I know that cosine is the x-coordinate, and so cosine of 17 pi over 6 is the same as cosine of 5 pi over 6, which is negative root 3 over 2. It's also this horizontal component. What else do we got? A few more. All right. Here are 4 more from your examples that you should definitely just try on your own. Okay, I'm going to pause the recording and I'm going to just work these problems and I'll show you the answers. So, you know, if you're watching the video at home, you should definitely pause right now because the answers are like just about to come up. All right, there you go. So I'll start off with sine of negative 3 pi over 2. First step is to find where is negative 3 pi over 2. Well, I know that positive 3 pi over 2, I go all the way down here. So negative 3 pi over 2, I'll go back 3 quarters of the circle. 1, 2, 3 quarters of the circle. Okay, I'm back up here at the top. Okay, there's not really a triangle to draw, so I'm just going to draw the coordinates. X is 0, y is 1. Well, I know that sine is the y coordinate, so I'm going to say that sine of negative 3 pi over 2 is the y coordinate, which is 1. Over here, cosecant of negative 7 pi over 6. Okay, well, positive 7 pi over 6 is a little more than pi. Okay, so there's pi, and then I go a little farther, okay, by pi over 6. So if I were to do that in the negative direction, I would go over here. This is negative pi, and then a little bit more negative than negative pi would be negative 7 pi over 6. Okay, so I draw my triangle. It's a 30, 60, 90 because of that. And what I'll do is I'll say, okay, the short leg is a half, the longer leg is root 3 over 2, and the radius is 1. This is negative because we're over here where x is negative, but this is positive because we've gone up. Okay. I know that cosecant is related to sine. So this is 1 over sine of negative 7 pi over 6. Well, the sine I found right here, that's a half. Okay, so 1 over a half, that would be a safe place to stop. Or you could just say that's 2, whatever you like. Okay, these were more of the same. Okay, we identified the angle. Okay, negative pi over 3. Okay, we go up pi over 3. We go back pi over 3. Okay, and then you just kind of do the same way as we've been doing. And then over here, secant. We know secant is related to cosine. It's 1 over cosine. So I'm going to need to find the cosine of 10 pi over 3, and then I'm going to flip it, basically. So 10 pi over 3, it's like, oh, man, that's not an angle I'm familiar with. Okay, I taught pre-cal last year, and I didn't just off the top of my head know where 10 pi over 3 is. It's like, okay, definitely bigger than 2 pi. So I don't really know. Okay, but you think to yourself, 2 pi is 6 pi over 3. So 10 pi over 3 is this 2 pi plus 4 more pi's over 3. So we know that 2 pi gets you back to where you started. And then we're going to keep going by 4 pi over 3. Now 4 pi over 3 is just bigger than 1 pi by pi over 3. So there it is. It's where regular 4 pi over 3 is. And I've got the cosine, it's negative half, once I did 30, 60, 90, and I did 1 over negative half, and that's negative 2. Okay. And so those were a couple of really genuine, fair practice problems that are indicative of what you'll see on the quiz. All right, so to wrap up, I'm going to have a couple of examples with, tangent and cotangent, just to remind you of how those work. And so you'll see on screen, you've got, I'm moving back up to the board, so I got to rotate the microphone. So hopefully it's catching me up there. This video isn't terrible, but it's my one shot at recording it. So, all right, negative 7 pi over 6. I think we already did negative 7 pi over 6. Okay, it's just a little more negative than negative pi. Okay, that's negative pi, and a little bit more would be right there, by 1 pi over 6. So I'll draw myself a little triangle. Did the best I could. Okay, the short leg is a half, the long leg is root 3 divided by 2, and the radius is 1. Right? And this one will be negative, that horizontal leg will be negative because we're over here in the second point. The vertical leg will be positive above the x-axis. Now, what I'm going to say is, there's a couple of ways you can do it. You can first find tangent and be like, okay, tangent is the ratio of the y to the x. Then you're going to flip it. But that's kind of cumbersome. I think what I'm going to do is I'm going to say tangent is opposite over adjacent. So cotangent must be adjacent over opposite. So the adjacent leg is right here. So it's going to be equal to negative root 3 over 2 divided by opposite, which is 1/2. And so what I'm going to do, if it's free response section, the quiz, the test, you're good to just leave it like that. We don't care. It's the same number. Put it on multiple choice, you got to recognize the right answer, right? So what I'm going to do is I'm going to do a little bit of flipping and multiplying, right? So it's negative root 3 over 2, and keeping, changing, flipping, depends on how you learned it, whatever. Okay, cancel off the common things. That's negative root 3. Okay, since it's perfect, I've got a couple minutes left in class. I've got one more example left on the note packet. Cotangent of 7 pi over 2. Oh, that sounds like something that might not need to find. All right, or maybe it's 0. I don't know. So 7 pi over 2, like, oh, that is definitely bigger than 2 pi, right? Because 2 pi is 4 pi over 2. Okay. So I'm going to say 7 pi over 2 is 4 pi over 2 plus 3 pi over 2. Okay. 4 pi over 2 is just... toolbars are showing. 4 pi over 2 is back to where you started. So it's like it didn't even really happen, you know? So what I'm going to do is I'm going to find 3 pi over 2 on the unit circle. I know where 3 pi over 2 is. It's 3. What's the circle? And I know the coordinates of that point on the unit circle. The unit circle has radius 1. So this will be x is 0 and y is 1. Now we don't have a triangle. So what I'm going to do is I'm going to find tangent and then I'm going to flip it. Okay, so tangent of 7 pi over 2. Or earlier I said tangent, that's y over x. So that's negative 1 divided by 0. That's, oh, that's a problem. That's not good. Okay. I don't like that. But the good news is, cotangent of 7 pi divided by 2 is going to be 0 divided by negative 1. And if you have nothing and you divide it up into, a bunch of different pieces, you still have nothing. And so you can divide 0 by a number. You can't divide a number by 0. And so the tangent of 7, or the cotangent of 7 pi over 2 is 0. And that's all I got for you for this week.